Hey there, science enthusiasts. Ever wondered how scientists separate and analyze different components of a mixture? Well, today we're diving into the colorful world of paper chromatography. And guess what? We're going to do it all with some fun claymation. First, let's talk about what paper chromatography is. Imagine you have a bunch of different colored inks mixed together. How do you figure out what colors are in there? Paper chromatography is the answer. It's a super cool technique that uses capillary action to pull solutes up through the paper and separate them based on their polarity. All right, let's get into the steps. Step 1, apply the sample. Take a strip of special chromatography paper and add a small dot of the ink mixture near the bottom. Simple, right? Next up we have step 2, developing the chromatogram. This is where the magic happens. Place the paper in a container with a bit of solvent at the bottom. The solvent will start to climb up the paper, carrying the different ink components with it. This movement is due to capillary action, and it's what helps separate the different colors. And finally, step 3, calculating RF values and making conclusions. Once the solvent has moved up the paper and separated the colors, measure the distance each color traveled from the starting point to the middle of the spot. Then calculate the RF value by dividing the distance traveled by the color by the distance traveled by the solvent. These values help us identify the different components in the mixture. Did you know that paper chromatography was discovered back in 1943 by Martin and Singh? It revolutionized the way scientists analyze plant constituents and other substances. Pretty amazing, huh? A few more things you might want to know. The chromatographic chamber can be made of glass, plastic, or stainless steel. And if a pure solvent doesn't give us the best separation, we can mix solvents with the right polarity to get better results. There's also something called ascending paper chromatography, where the solvent rises up the paper, pulling the components along with it. It's fascinating to see how different techniques can be used to achieve the same goal. So, there you have it. Paper chromatography might seem like a simple technique, but it's incredibly powerful and has a rich history. Next time you see a colorful diagram in your chemistry book, you'll know just how those colors were separated and identified. Thanks for watching, and keep exploring the wonders of science. Catch you next time.